Hello, welcome back to Cracking the Cryptic. And yeah, there was a very amusing comment on yesterday's video when I said that we like to show puzzles with fewer rules and easier to understand for newcomers. Somebody said, "Please, sir, have you ever seen the puzzles Simon solves on the channel?" And that was a fair point. What we like to do, I mean, I suppose the policy is that we like to have some puzzles that everybody can understand and have a go at. That's the theory. And in that vein, today I am doing a puzzle that just has killer Sudoku and diagonal constraints, nothing else. So at least relatively simple to understand. I suspect it won't be relatively simple to solve because it's by Quarter Through, also known as Jeremy Butler, whose puzzles we have been solving on the channel for years, and they've been getting consistently harder, I would say, but that may be exaggerating or extrapolating too far from very little info, but I'm not expecting it to be a free ride, I'll say that, but you can judge from the video length if you want to have a go. Now, first of all, on Patreon, with still 3 days left to enter the Quite Approachable Sudoku Hunt, we have had hundreds and hundreds of entries. A huge percentage of our patrons have entered, which is fantastic. Thank you so much. If you support us at all on Patreon, let alone if you've entered the competition. For the paying patrons, there's also a crossword video today, me solving or having a go at solving the incredibly weird and esoteric Times Monthly Club special, which I really enjoy the tussle with, but by goodness, it's a tussle. So that's on Patreon, along with all of our other content there. You can look on if you want to engage with the channel more. Oh, thank you so much to Long Way to Tipperary, who sent Simon and myself this very kind Valentine's card. We take awesome to a whole new level, apparently. So that's good news. We do try, although I'm not sure that we think of ourselves as awesome on a day in, day out basis. Yes, if you want to engage more with the channel, there's all the apps and the merch, all on the links under the video, along with Sven's SUDOKU PAD, the Discord server, and the way to Patreon. But the first link is to this puzzle, which features killer Sudoku rules. So in the cages, the digits cannot repeat and they must add up to the number given. There is one cage with no number given in a plus shape, sort of. And if you watched Simon's video a couple of days ago, you'll see how much a cage like that totally threw him, although this one is not quite so otiose. This cell can't be the same as those two, so their cage has meaning, whereas in Simon's puzzle it was just there as a relic of a former version of the puzzle, I think. Here it sort of provides some symmetry and it does have meaning, it just doesn't have its total. Anyway, those are the killer rules. On the diagonals, digits cannot repeat, so that's a set of the digits 1 to 9 and also on the other blue diagonal. So those are the rules. Do give it a try if you want. I'm about to start now, although full disclosure, I got this far in a video. I looked at a couple of cages on the right side of the puzzle, and then some of the most intense drilling from the building works next door started up. And I don't want to have to junk the whole solve for the sake of Quarter Through. So my first two thoughts come from an earlier attempt. I have had to wait till the builders have gone home because they were absolutely manically at it today. I'm really hoping the darkest hours before the dawn and they're approaching the final phase of the build, but there's no sign of them ending. Anyway, let's get cracking. Right, so what I did notice is that this 16 cage can only be filled one way, with 5 digits. The minimum 4 digits are 1, 2, 3, 4, and then you have to add a 6, and there's no other way to make 16. So those are the contents there. Then I noticed that this 17 cage must have 1, 2, 3 in it. We sometimes see that in 5 arrows in arrow Sudoku lately, because if you have 5 arrow cells that can't see each other and they're on 2 arrows, the maximum total for those arrows is 17. So those 2 arrows have to have 1, 2, 3 on. Here it applies in a cage, which is a slightly more normal setting perhaps. And I don't really know what this means. We've got 1, 2, 3 up there and 1, 2, 3 down here. So I suppose these cells can't use 1, 2 and 3 because they must be in those two cages, and that uses them up for columns 8 and 9. But apart from that, I haven't actually learnt that much, and now I am flying blind again. Ah, well, I shouldn't be. I've got a 35 cage over here. That has to be 98765, the maximum sum of 5 different digits. Ah, right, and the 33, this has to be similar to the comparison between the 16 and 17 over there. I think the 33, it certainly has at least 9 and 8 definitely in it. If it didn't have a 7, the maximum it could be is 98654, which is only 32. So it also has a 7. So this is very similar. 987 are definitely used in both cages. I don't really know what it means. I don't really know where I'm going at the moment. The other cages don't seem so useful. Ah, right. Okay, here's something very interesting. Look at the pattern made by the two diagonals. I mean, it's a very obvious pattern. You know exactly what it looks like. It's normal. But I'm going to colour those cells. I'm going to colour them purple. I'll make the middle one blue flashed. Now, if I was adding the total value of these cells, it would be 45 for that diagonal plus 45 for that diagonal, but the 17 cells involved don't add to 90 because this one would have been counted twice in those two 45s. And look at the regions that encloses. So what I'm going to do is add up the value of the whole grid. This is my plan. So I'm just going to write some numbers in here. This is nothing to do with Sudoku. I'm just totaling up. So those two sets of purple cells add up to 90, allowing for this to have been used twice. So I'll come back to that. This region enclosed on the left is 3 cages that average 33. There's 3 of them. That adds up to 99. Let's colour it as well. That's 99. And I'm going to add up all these totals in a minute. We've got 3 cages at the bottom, 32, 31 and 27. 59, congratulations if you got to 90 before me there. That is again, so it was 99 on the left, 90 down here. Let's colour them green, say, and over here, this area is entirely 3 cages again. 16, 33, wow, only 61. That's quite surprisingly less than 99 or 90. That's interesting. Now, this is a harder area. It's certainly not all covered in cages, obviously, and this cage doesn't have its total. But I'm going to add these two, and the reason that's 33 more. The reason I think that's interesting is because, I'll tell you what I'm also going to do. I'm going to add box 2. Which hasn't really been used much, just 2 cells of it. So I'm going to add that again. Let's make that grey. Actually, the way I should have done this, and I'm going to just change horses in midstream there. So sorry, I hope you know the secret, which is that every box in a Sudoku adds up to 45. Same as every row and every column, because that's the sum of the digits 1 to 9. If you don't, make sure you tell your favourite people. Now, this area adds up to 45 because it's a box, and that is just normal, just by the rules of Sudoku. Now, what we have added up is the whole grid except for that cell, but we've counted those 3 twice. Now, I'm going to add up this total and see if taking it away from the secret times 9, i.e. the sum of the whole grid, if one box adds up to 45, obviously there are 9 boxes, the whole grid adds up to 405. That is the big secret. Now, adding up these, we have 10, 18, carry 1, 10, 19, 28, 38, 41. Oh, that's not the total I was hoping for. So the total of all the coloured areas, counting these twice, is 418. The difference between that and the total of the whole grid is 405. Therefore, these 3 cells minus that one equal 13, and that is disappointing. I was hoping they would equal either 25 or -5, but they don't. Okay, bother. But I'm still going to remember this 13 difference, and I'm going to colour those cells. What I'm going to do is undo all that. 13 is the number. Let's get rid of all the colouring that I've done because it's become valueless in a way. But those 3 cells were counted twice, minus that one equals 13, and maybe I will get to use that later. I'm really annoyed. I thought this was going to be the way in, and I don't think it is. However, what I did notice while doing that, and this might be valuable, is that this area added up to 61. And that is quite small when you consider that box 6 on its own adds up to 45. So let's take that out. These 7 cells add up to 16. Well, the minimum they can be is 1, 2, 3. They could be 1, 2, 3. They couldn't. I'll come back to that. So that would be 12. And the maximum this can be, therefore, is 4. Now, what I'm coming back to is they can't both be 1, 2, 3, I don't think, because this will have to have either 4, 7 or 5, 6 in it, if that was the case, and that will clash with the 4, 6 in here. So at least one of those areas has to be more than 1, 2, 3, and that's going to take the highest degree of freedom off there. That cell now becomes 1, 2 or 3. Oh, right, okay. Okay, the way I should be looking at this is considering box 6. I can probably go and do the same in box 4 afterwards. But right, my next question is a totally different question in a way. Where do 9 and 8 go in box 6? Oh, and this is a lovely answer, because they can't be in the 17 cage. The maximum digit you can have in this 5-cell 17 cage is a 7. They're obviously not in this 16 cage. So 9 and 8 are in the 28 cage. That leaves 4 digits that add up to 11. And if you've done much killer Sudoku, you know that 4 digits adding up to 11 are 1, 2, 3, 5. It's the only way to have 4 different digits add up to 11. So this cage is a 1, 2, 3, 5, 8, 9 cage. Now we can look at box 6 and say, where does 7 go? It doesn't go in either of the 16 or the 28 cage, so it must be in one of these cells. I'm just going to remove the pencil marking. 7 is in one of those 2 cells, and we now know how the 17 cage is made up. If it's got a 7 in it, it's 1, 2, 3, 4, 7. What else does that tell us? That looks across the grid and tells us 7 is not in these cells because it's in one of those 2. So 7 is now definitely here. Yes, and I was wondering if we can do the same thing with the 99 total of that area. And I bet we can. I think this is how Quarter 3 has designed this puzzle. So this area totals 99. Take out 45, the total of box 4, and the remaining cells add up to 54, which seems a huge number, but these 2 could both be 9, 8, 7. Again, they couldn't be, but if they were, that would be 48, and this cell, to take the total up to 54, couldn't be more than, no, would have to be at least 6, because 9, 8, 7 are maxima there, so the minimum here is 6. However, I don't think it can be 6, because that would put 9, 8, 7 as pairs there. This would have to be a 6 and a 5, and this pair, after 9, 8, 7 in this cage, it's either 6, 3 or 5, 4 to make it up to 33. That couldn't go with a 6, 5 pair, so it's exactly the same as over here. We can take out the extreme degree of freedom and we get 7, 8, 9. Now, next question, very similar to asking about 8 and 9 over here. Where do 1 and 2 go over here? They can't be in this cage, which is either 9, 8, 7, 6, 3 or 9, 8, 7, 5, 4. So 1 and 2 are in the 31, and that leaves 28 in 4 digits, which doesn't have just one way of doing it. Now, that's annoying. That is not quite analogous to this, which only had one fill. This one has 2 possible ones. It must have 9 and 8 in the cage, and 1 and 2, which add up to 20, but then it's either 7 plus 4 or 6 plus 5 in the rest. But there's no 3 in those possibilities. Oh, yes, this is okay. It will work exactly the same way as this in the end. Exactly the same way as this box did. There's no 3 in the 2 possibilities I listed for this cage. There's no 3 there. So where's the 3 in box 4? It's in one of these 2 cells. Yes, it is. And therefore 33 here is 98763. With a 3 in one of those 2 cells. So these can't have 3s in. And now there must be a 3 down here. And now that there's, there's no 7 in those cells. I knew that because of the 7 over here. Oh, maybe I'm getting stuck now. There's a 3 there. This is either 981274 or 981265. Right, where does 4 go in the box? Oh, that's lovely. Where does 4 go in this box? Can't be in those cells or those cells. So it is in this cage, which is therefore 981274. So that one was either 7, 8 or 9. And now 1, 2 and 4. I thought that was going to prove, yes, 5 must be in those 2 cells because we need a 5 in the box. So it is in one of those 2 cells. That's not a 5. Sorry if the pencil marking is just getting a bit heavy, but you know what I'm like. So there's a 5 in one of those 2 cells. There isn't a 5 up there. Oh, and look at the middle row. That's beautiful. Where's the 6 going to go? The 6. We haven't thought about 6s yet. I'm thinking about them now. And this cage doesn't have a 6 in it, and this cage doesn't have a 6 in it. The only place for 6 in the middle row is slap bang in the middle of the grid. And the first full digit we get is in the middle and is a 6, and that is so unexpected. We occasionally get 5s because of pure symmetry, but that is a real surprise. Now, it doesn't really help me with that 13 total because it's such a middling digit, but okay. I don't know. Oh yes, look, 6 is not on, well, it's now on both diagonals, so it can't appear anywhere else on a diagonal. And I include in that these 3 cells. Why is that interesting? Because that means 6 has to be in these 3 cells in box 9. If it's not there, we know it's not in that box. So it's in one of those. The remaining cells add up to 26. They are definitely, I think they probably always were going to need a 9 somewhere in the box. That's 15. The other 3 digits add up to 17. That can't be, it could be 753. They don't need an 8. Bother. No, 17. That can't be 753. They do need an 8. 9, 8 and 6 is 23. Then the other two digits add up to 9. They're either 7, 2 or 5, 4. And maybe this thing peters out a bit now. Let me just remove those pencil corner marks. Might leave those behind. There's a 5 there, there's a 3 there. Now, is there some digit here? Yes, there is. 6 in this box is not in those cells. So it's in one of those 2. Now, that's good, because again, 6 can't be on this diagonal. So now 6 is in the 15 cage. And that is much more helpful than this one, because the 16 cage can't have a 9 in it now, or an 8, or a 7, because then it would be 1, 1, 6, 7, and that would repeat a digit. So if 9, 8 and 7 can't be in the 15 cage, where are they in box 3? Well, they're on the diagonal. That's so clever. And then these must have a 5 in, because we need a 5 in the box. And then the 15 cage is made up 6, 5, 3, 1. That adds up to 15. That one is not 5 or 6, because not 5 or 6, because we know they're in this box. So it's 1 or 3. And that's still not really doing anything with my blue and greens. But we've made real progress here. Right, 2 and 4 have to be in this bit of the box. So they're not here in this cage. 6 is, so 6 is not over here. Now 6 is in this bit of the cage. It's all funneling around and back. It's so clever. Now let's have a look at the diagonal. 9, 8, 7 and 6 are used up. So the other ones are 1, 2, 3, 4 and 5. This one can't be a 5 because there's a 5 over there. There's a 3 over here, so that's not a 3. And that's all I can do. Now, what about this? There's a 6 in here. 9, 8, 6, and either 2, 7 or 4, 5. I don't think it's as helpful. Bother. This is either 6, 1 or 6, 3. Oh, right. No. No, I was wondering if that meant whichever digit wasn't a 6 was also there. I think it does, because this cage needs a 1 and a 3. And there is either a 1 or a 3 here. So for this cage to get its 1 or a 3, it has to go outside this box where that 1 or 3 appears. So it's got to go in there. And that gives us a pair in column 6, a weird pair that stops this being 1 or 3. That is 2 or 4. 3 is now definitely on the diagonal in box 7. Doesn't really help, does it? This seems now to have to be a 7-4 pair, because they're the only places where 7 and 4 can be in the box. I don't quite know how that happened, but it's helpful, because now this is a 1, 2, 3 triple. Ooh, is it helpful? It hasn't stopped this being 9, 8, 6, 7, 2 actually. I thought it was going to. It doesn't. Right, 4 and 7 there. So there's no 4 there. That's not a 7. 4 must be in one of those 3 cells. In box 5, so it's not there, and it must be in one of these 3. 7 is not so helpful. It could be anywhere there. Now, is there another? It's not quite so easy. Whichever digit goes with 5 there is also here, but I don't know which one it is. Oh my gosh, look at that. Look at that. A 1, 2, 3, 4 quad in column 9. How did that turn up? Something to do with having made this 1, 2, 3. Oh yes, this can't be 1, 2, 3. There is a 2 and a 4 in that section. Yeah, and that kind of will lead to what that is. But anyway, 1, 2, 3, 4 quad. That is looking at that cell, which can't be a 4 now. This now can't be a 4. There's still a 1, 2, 3, 4 quad here, so that can't be 1, 2 or 3, and this can't be 1 or 3. That's a 6, and this isn't. And whatever this is this, so I'm going to colour them. Trouble is, it could be a 3 in one of those 2 cells, or a 1 there, and I don't know which. Ah, come on. 2 and 4 are definitely in use here. That can't be a 7 anymore. These 3 are 5, 8, 9 as a triple. Ooh, this can be 8 or 9, but only by making that cell 8 or 9 in the 32 cage, because it sees all of those. come on, puzzle. You've been really interesting to this point. What am I missing now? This is useless, this cage. 18's too middling a number in a way. Oh, hang on. 6 there, 6 there. There has to be a 6 here. So this is a 3-6 pair, just as that became a 4-7 pair. This is now a 3-6 pair. And there's no 6 here. So the 6 in this box is now in this cage, which adds up to 27. But that is a horribly middling number. 6 is in there somewhere with, and 3 is, what good is that? Nothing. Still, this orange could be a 3 there or a 1 there. Now 3, 6 here, 5 we know is there. And whatever this goes with, oh, hang on, look at that, 6, 7, 8, 9, quad in column 1, just like the 1, 2, 3, 4 on the other side. That's going to make this cell a 5, that one a 3. We are cooking with gas now. This can't be a 5. Now this cell is going to be the same as this one because it has to appear in the 31 cage, and it can't be in that box. Come on. There's definitely a 6 in one of those two cells because it's not down there in the quad, so that's not a 6 anymore. Also, this can't be 7, 8 or 9 because of the 6, 7, 8, 9 quad. That's not 3 or 5 as well now. These 3 are 1, 2 and 4 in some order. What does that do? It doesn't do much else. But all 3 of these areas have been useful by not having a 6 when it was on the diagonal. So that's forced 6 into lots of these boxes, but it won't be in the 18 box. Because it's in here. Well, it might be there, but I don't know about that. 7, 4, 3, 6. Come on, think about it. 5 can't be there. So 5's in one of those 3 cells in box 5. One of those 3 and not there. That's not very helpful. Now, am I missing some other? Look at this. I am missing other triples and things. 1, 2, 3 triple now. So that's not 1 or 3. That's not 1, 2 or 3. 2, 3, 4. These are from 5, 6, 7, 8, 9. 4 is definitely in one of these 3 cells because it's not anywhere else in the column. Now, is it in the box? Could be. 9, 8, 6. 9, 8 and 6 are definitely in the box, and it adds up to 32. So if 4 is in it, it's 9, 8, 6, 5, 4. But if 4 is not in it, it's 9, 8, 6, 7, 2. I think I've been through that before. Oh, 6 is in that cage and that cage. So it can't be in these areas in box 8. It also can't be in any of those cells. So 6 in box 8 is in one of those two. Doesn't really do anything, but it's quite interesting. Oh, crikey, this puzzle doesn't give up, does it? What on earth are we meant to do next? 98654 or 98672. None of those include a 3. So, oh no, 3's in there. I was going to put 3 on this diagonal, but that's absolute bobbins. Now, there was a 1, 2, 3 triple over here. I bet, yeah, there's a 7, 8, 9 triple. Doesn't do a lot. Or does it? 2 of those are from 7, 8, 9. No, it doesn't. Whatever isn't in this part of the cage, yes, is in there and is the same there. Now, this is 7, 8 or 9, which is either a 7 there or an 8, 9 there. Oh, it's just petering out a bit now. What about this 1, 3 pair? That doesn't really help down here because this box could never have a 1 or a 3 in it. Okay, what about the total? Now, I've never used this total of, what was it, 90? Yeah, it is. So let's think about that. 90 minus box 6 leaves, box 8, I mean, leaves 45. Oh, what's the maximum that this could be? It can't have 987, so the maximum it could be is 654, which is 15. That would leave a minimum of 12 here. The maximum this can be, remember it has a 6 in it, is 986. So that leaves a minimum of 9 here. So we've got a minimum of 12 and a minimum of 9. That's a minimum of 21. That means the maximum of the rest of this box is 45 minus 21, which is 24. And that means the minimum for this cell to make up the 31 cage is 7. And we know it's not a 7, so it's an 8 or a 9. Is that right? Is that logic right? 654 are the absolute maximum there, 15. So the minimum is 12. 689 are the maximum there because 6 is included. So the minimum there is 9. 9 and 12 is a minimum of 21. That gives a maximum of 24. That gives a minimum of 7. Yes, that works. So that's 8 or 9. And there's not many degrees of freedom. With 7 having been the minimum there are 2 degrees of freedom down here. So 9, 8, 6, 23 would leave 9 here. This either adds up to 9, 10 or 11. I don't know how that's made up though. And what are the possibilities here? 654 would definitely leave this being 3, 9. That's the only way you could get to 12 without using 5 or 4. 653, which is 14, would leave this being 9, 4. So it's 9, 3 or 9, 4. There are 2 more possibilities. 652 is impossible because that would have to add to 14 and would use either a 6 or a 5. 643 is not possible because that would leave 1, 2, 5 on the diagonal and would clash with that cell. Wow. So we're down here to either 9, 3 or 9, 4. And that means there is a 9 there. There isn't one here. There is one in this group of cells. Okay, I'm going to take out the 8 pencil marks because I now know there's a 9 and a 6 in this group. That's not a 9. These add up to 15. They had a maximum of, they had a maximum of 23, and there's 2 degrees of freedom. So you can't replace the 8 maximum with a 4, because that would use 4 degrees of freedom. So there's no 4 in this bit of the cage. This is either 986 or 976 now. That is the only way it can be filled. Yes, the 4 goes here. That's right. Wow, that's mad, but that is right. There might have been some other way of getting at that, I don't know, but that is brilliant. Now, there's a 4 there. Okay, what have we done here? We've got a 9 in one of those 2 cells, so yellow is not a 9 because it can't be there. So there is a 9 in these 3. That's probably not overexciting. Oh, this is either 9, 4 or 9, 3, so that there is a 5 in these. It's either 6, 5, 4 or 6, 5, 3. So there isn't a 5 on the diagonal there. The 5 on the diagonal is now here. Feels like running a marathon, this. And I have a feeling I'm only about halfway, maybe hitting the wall. Right, 5 is there. So this is 6, 5. Well, this is 6, 5, 4 or 6, 5, 3. Oh, that means 2 and 1 are both on the diagonal along with 3. This isn't 653 because I established earlier 3 was on the diagonal there. Aha! This is 654. There's no 4 on the diagonal. That's 1, 2, 3 on the diagonal. That's a 4 on that diagonal now. And we've got a sort of 1, 2, 3, 4, 5, 6, and a 7, 8, 9 on that diagonal. Wouldn't you know it? This is now a 9, 3 pair. 4, 5, 6, 9, 3 adds up to 27. That's good. Right, 9, 3 there. Now, if we knew the 31 cage had to have a 9 in it, that would be 9. Ah, there's no 4 in this cage. So, didn't that matter? It's got to have 9, 8, 6. And now it doesn't have a 7. No, hang on. It's not 9, 8, 6, 5, 4, so it does have a 7. It's 9, 8, 7, 6, 2. So there's a 2 in this bit of the cage, and not a 9 or a 6 because they're over here. There's definitely a 2 there in one of those two. And that's all fitting. Okay. 3, 9, 2, and either 7 or 8. So 1, 4, 5, 6 goes in this area, and that adds up to 16, plus either 7 or 8, plus either 8 or 9, which have to add up to 15. Well, it has to be 1, 4, 5, 6, 7, 8. There's no 9 in this cage. Oh, I thought that was definitely going to be a 9. Right. 1, 4, 5, 6, 7 there. So there's no 7 here. There's no 8 here. This is 5 or 8 on the diagonal. Let's take out the corner marks because we basically used them to the max. There's no 4 there. That's not a 6. In fact, there's no 6 down there at all. There's a 1, 2, 3 triple. Well, this must be 8 and 9. That's the only place they can go in the row. So that's a 7. Oh, we're getting there now. This is happening. This is happening. 1, 2, 3 triple. So this is a 5, 6, 7 triple. And this is a 1, 4 pair down here. Wow. Right, on the diagonal, 4, 5, 8, 6. That's now not a 4. So that's a 1, 2 pair, and that is a 4. So let's take 4 out of the cage. This yellow is no longer 8. So yellow is 7. That takes 7 out of the cage. That's also not a 7 anymore. This is a 6, 8, 9. I mean, I'm going to take the corner marks out, I'm afraid. They're not really helping anymore. Now the diagonal, 4, 5, 8, 6. So 5 can't be on the diagonal here, so it's in the 18 cage. That's a start. There, 7 is not there. This is a 6, 8, 9 set. 4 is also not in those or on the diagonal, so 4's in the cage. And the other two digits add up to 9. 6, 8, 9, 5, 4. So these are from 1, 2, 7, 3. There's got to be a 9 on the diagonal, which is in one of those two positions. Hang on, let's just shimmy down some pencil marks. That couldn't be 7. These can't be 8. That's 1, 2, or 9. 5, 7. That can't be 7. 4, 6. These can't be 8. Oh, that's not quite as helpful as I wanted. Oh, that can't be 7. There is only one place for 7 on the diagonal, and it's there. That stops that being a 7, so we know where 7 is in that box. And we know where 7 is in row 1, because those rule out all of those cells. We've worked out it can't be there from the maths, and it can't be there from that 7. So we get a 7 here, which fixes this as a 5. 6 and 7 are done. Now, up the middle, 1, 4, 5, 8, 6, 7. We have 2, 9, 3 in... Oh, well, of course, it's an untotaled cage, irritatingly. There isn't a 9 in the green cell because there's a 9 in one of those two for the diagonal. Come on. That can't be a 7 anymore, obviously. 8 and 9 must be in those two. Not helpful. Now, 5, 4 up here. What pair does it go with that add to 9? Not 5, 4 again, obviously. Not 7, 2. It's either 6, 3 or 1, 8. In which case this is either 6 or 8, because whichever one is featured can't be in box 1. That means there's no 2 in this cage. There must be a 2 on the diagonal in one of those two positions, and these two aren't 2s, and the 2 in the central box is right here in green. Now, these 3 minus 2 we're going to add to 13, I remember, in which case these two add up to 9. There's, of course, still 2 ways for that to work. Bother. All right, not to worry about that. They add up to 9. 5, 4, 3, 7, 6, 8, 9. What am I missing now? That can't be a 6. Come on. There's something shouting out somewhere at me. What is it? 8, 9 pair, 7... Yes, they can't have a 2 in. That's a 3, 9 pair, and that's made this blue cell a 1. These two blues add up to 9, so that's an 8. And now this is 8, 5, 4, 1, and we know where the 1 goes, it's there. So that fixes the diagonal, probably all of it. No, not quite all of it. We're left, yes, all of it is done, because we have the 1 in column 6 now. Now, across the top, 2, 4, 5, 8, 7, 1, 9, 6, 3, and that's a 5. These don't have a 3 in, so orange becomes 3, which fits with the middle box. That's not a 9, it's part of an 8, 5 pair. This is the only place for, no, it's not. There's no 1 here, that's a 2, 8, 9 triple, so there's 1 there, 2 and 3 are done, and that diagonal is finished. I just need to do this 5, 8, and I've finished the other one. There's no 3 here, so there's a 3 in the cage at the bottom. Come on, come on, come on. Gallop through the rest, he says, hopefully. Yeah, that fixes 9, 3. The 9 can't be here, so... Oh, that's looking at a 6, 7 pair, so that's where the 9 is. Then these can't have 3, 5, or 8 in, so that's a 1, 2, 9 set. That's a 5, 8 pair. That can't be 8, so 8 is there. This is 9. Now that's left a 1, 2 pair. This 2, 9 has been resolved by a 9. That 2, 1 gets resolved. We are flying in a way. Now, 7, 3, 9. Look, this is a 2, 4 pair, and this is where this cage really does come into its own. Unlike Simon, I knew it would be useful, and it is. I get a 2 there, so this can't be 2 in the same cage. 4 and 2 are resolved thusly. A 1 there, left with a 2, 4 pair. Actually, they can be filled in without worrying about the pencil marks. This 9, 3 pair's resolved. This is probably done. 6, 5 pair. This is an 8, 9, 6 next to it, and now I'm just finishing off, I reckon. 9, 8 there. This is a 2, 1 pair. Oops, 2, 1 like that. 6, 7's been resolved. So has 2, 8. So has 1, 4. That fixes 4 here, which I can go up and do 5, 4. Then I can come back and do 5, 6. Now I can do 8, 5 on the diagonal and finish off in box 6 with an 8 and a 5, and that is a beautiful puzzle. It is so elegant the way all the deductions keep mounting up and then bouncing back on themselves all over the place. I don't know how necessary the colouring and stuff was. It was interesting to do, I thought, but I'm glad that the adding up of the whole grid at the beginning wasn't totally valueless. It wasn't the right approach, but it did give me this useful 13 deduction, which did help later. I mean, I'm sure it wasn't necessary, but At least I was able to use it. That has been good fun. Well done, Quarter Through. That's a great puzzle. Thank you for following as usual. Well done if you had a go at the puzzle first and did it. That's quite a tough one, I reckon. But pleased to get through it. And do check out our stuff on Patreon. Subscribe and like. Come on, engage with us. You want to. We want you to. Thanks for watching. Hope to see you again soon on the channel. Bye for now.